Okay, welcome to our third session. So in this last session of today, we're going to look at saving and investment. Now we're going to extend our model with investment and saving. So maybe I can put some heading here. Now, of course, it's a bit difficult to study investment and saving in a static economy, right? Because there is no time in our economy. This economy is static, okay? But we can still do it, as I will show you in a moment. All right. So in a dynamic economy, it is much more clear. At least you know that, for instance, if there is investment and there's depreciation, right? If there was time, then we could specify an investment function. Then there's depreciation. Then there is net increase in capital stock. But in a static economy, we have to do something else. All right, and that something else is this. So we're gonna assume that there will be an investment good, okay, and that investment good is gonna be produced by all other goods in the economy. Okay, so these are again technical coefficients, and we're gonna have something like this. Okay, so what is that? Now, lambda I will be called investment level. Okay, investment level, and these are technical coefficients that tells me this. If my investment level is lambda I, I'm going to use from the J good lambda I times Aij. Okay, so these technical coefficients are different than our original A matrix. Our original A matrix was this, right? It was the technical coefficient. It was the matrix of technical coefficients between the produced goods. Remember that? Now we have a vector of technical coefficients. Okay, and for the investment good to be produced, for instance, I need 2 buildings, okay, for 1 unit. Let's say Aij is 2, AI1 is 2, let's say, okay. I have 2 units for 2 units of the first good, and for lambda I units, I need INVJ units from the first good, INV1 units from the first good, INV2 units from the second good, etc. So you may read this equation similar to this. Remember that? So to produce 1 unit of good J, I needed Aij units of good I, right? So to produce 1 unit of investment good, I need Aij units of the good J. Okay, so in total, if my investment level is lambda I need lambda I times Aij units of that good. Okay, so then we want to calculate the total investment spending, right? We want to calculate total investment spending. So we have N goods. Let me use J. So PJ, INVJ, right? That's total spending now. This one is total because I spent INVJ units for the J good when my investment level is lambda I. Okay? So in total, I make this investment spending. Again, this is a nominal variable. This is total investment spending now. So if you put INV here, so you have PJ, lambda I, AIJ, right? Now be careful. Lambda I does not depend on J, right? So lambda I goes out. We have J from 1 to N, PJ, AIJ. Okay? So these are, again, technical coefficients for the investment good. And we define this animal, as a price index for investment. Okay? So total investment spending is then this. Okay? So this is now a price index that reflects the importance of each different good. So it is a weighted average, if you think about it. Okay? And your investment function is basically your investment level, lambda I, times the total price you pay for the investment goods. And of course, it depends on technical coefficients because you need different units from different goods for making the investment. Okay? So that's the investment part. Is that clear enough? Okay. So now I can talk about saving. So how do we model saving? Well, first we have to be specific about who's gonna save, right? And typically these are the households, right? In the economy, remember we have households. We have households defined in this set, and each household has a utility function, and that utility function depends on the consumption of produced goods. Okay? Now, what we want to do is to extend this utility function in this way. We're going to write UH as a function of the consumption goods as typical, and then we're going to create this new consumption good M+1. Okay? And that will be our saving. Okay? So for instance, you may imagine this function to be like C1H alpha 1, C2H alpha 2, dot, 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 CNH alpha N, and CM+1H alpha M+1. Okay, let me just, yes. So once you do that, okay, once you do that, of course, there is a solution there, right? Because you're going to find CM+1H depending on your prices and factors. And that, so that will be, if you think about it, so that will be depending on the price associated with it. Okay, so if we want to, so maybe I can reserve some space here. So total savings by private agents Now it will depend on these because remember the budget constraint. The budget constraint was like this, CIH. Now you have CM plus 1. That's the thing that you are not spending, right? So this will be equal to from K omega K EKH, right? So then the total saving will have a monetary equivalent, obviously, and we're gonna sum over the households. Okay? And that will depend on prices and so factor prices, so product prices and factor prices through this. Okay? So if you imagine a simpler example, you have first good, alpha 1, you have second good, alpha 2, right? And you have the m plus 1, and this is 1 minus, let's say, alpha 1 minus alpha 2. You have P1, C1H plus P2, C2H plus Cm plus H equals omega 1 EK1, so this is E, plus omega 2 EK2. Sorry, EK, sorry, this is not correct. Omega 1 E1H, omega 2 E2H. Okay, now if you solve this problem, you of course find it as a function of factor prices for each household, then you sum over households, you find the total saving, and you basically use the price index to find the monetary value. Okay, that's it. Then you also have this, of course. Is there any question about this, the saving part? It's all very simple. So this is like a trick. We basically, I mean, look at this budget constraint now. If you look at this budget constraint, I basically tell consumer cares about saving. Why? Well, we don't know why. Forget about it. This is a static model, but it cares about saving. That saving becomes, at the end, investment. Investment and saving will be equal in equilibrium in a closed economy and with no government saving. So private investment will be equal to private saving. But now this variable becomes a consumer's choice. There is a return and there is an implicit cost, right? There's marginal utility, and there's a cost of not spending that money to consumption. Okay, so there's an implicit return there, and then the total saving can be expressed in this way. Okay. Now, the last thing to do today is to think about the macroeconomic identities. All right, so let's think about some macroeconomic identities. So if you have consumption and saving and some taxes, so now this is consumption, this is saving, and this is tax, right? This must be equal to what? Now, this is total income, right? This must be equal to what? This must be equal to, in a closed economy, total expenditure. Okay, again, this is consumption. Now this is investment. Okay, and this is government spending. Now, what do we know from this? Well, we know saving will be equal to investment plus this. What does it tell me? If the government wants to spend more than the tax, okay, then this must be covered by the savings. All right. So in our framework, of course, this is for closed economy. Okay, this is for closed economy. So private saving, this is our notation now. Private saving will be so how do I write it? So private saving will be investment. Now investment depends on this and lambda I minus D, right? Because D was the revenue minus expanding, revenue minus spending. So the deficit could be expressed in this way. All right. So the equilibrium system is now, of course, much more complicated. I'm gonna leave it for the next lecture because it will take too much time. So next week we're gonna discuss chapter 4, equilibrium system. Okay, and then we're gonna look at chapter 5, I guess. Let me just double check it. I'm a bit disorganized today, so oh no, okay. After we discuss the end of chapter 4, okay, the equilibrium system and the rest, we're gonna start working on chapter 6. I'm passing chapter 5. All right. So next week we're gonna start working on social accounting matrices and calibration. Okay. Yes. So now I can respond to your questions. We have much time, so we can discuss anything that is not very clear or anything that remains unclear. It's all very simple. It's just notation. Investment now is defined a little bit differently than what you've seen before in other classes, because now what we think of investment is like many other goods. All right, when you invest, let's say you are opening a new factory, all right, you require many different goods to open that factory. If you want to increase the capacity of your factory, if you want to increase your capital stock, so capital is not now a single entity, right? Once you start talking about investment and capital, you are talking about many different goods. So each good is required in a fixed proportion, that a vector, right? So if you decide on how much to invest your lambda I, then you require particular amounts of each and every good in the economy to create your investment good. And then that investment good, of course, is a price index, because each of these produced goods are have prices in the market. And if you want to make the investment, you pay for each of these goods at a fixed proportion. So there's then this price index Pn+1. So that's the investment part. In the saving part, we just assume that consumers care about saving their money. Okay, so here, since the model is dynamic, we have to introduce saving in one way or another, and that's the simplest way to think about saving in a static economy. Because in a dynamic economy, in a much more realistic model, of course, I save today, I put this saving into some asset, and that asset will have a return. That return will be obtained by myself tomorrow, so that will be financing my tomorrow's consumption. Okay, so that is of course more realistic, but in a static framework, that's the simplest way to think about saving. Okay, so anything that is not clear, I can now explain. We have time. Okay, then. So next week, Wednesday morning, all right? So don't miss the class. Wednesday morning, we're going to be looking at the end of chapter 4. So we're going to look at the dynamical, the equilibrium system. We're going to show that in the large model with, government, taxes, investment, saving, how can we define the equilibrium? Then we're going to start working on chapter 6 of your textbook. So we're gonna look at a macroeconomic SAM, and we start discussing calibration. Okay. All right then. I'm ending the session. Mustafa, we can meet at 2:30. All right.
Okay.
All right. Okay. Bye bye then. Have a nice weekend.
Teşekkürler.
Bu linke geleyim değil mi hocam?
Evet, evet.
Tamamdır.